International Axial Flow Combines, the world's most advanced harvesting machines. The Axial Flow Combine, profitability through innovative technology. Axial flow design that incorporates multiple pass threshing and separating for large volume potential with less grain damage. From initial crop contact to final grain tank transfer, the Case International Axial Flow Combine is the clear choice for America's farmer. In this program, we will examine the axial flow process, basic settings and adjustments necessary for corn and wheat harvesting, and methods of determining and eliminating crop loss. We will also examine the attachments and options available to make your work more efficient. More specific information on all aspects of combine operation is available in the Case International Operator's Manual, the Combine Handbook for Axial Flow Combines, and the Axial Flow Productivity Guide. Rules for safe operation of the Case International Combine can be found on pages 3 to 6 of the Operator's Manual and pages 3 to 12 of the Combine Handbook. Please take time to familiarize yourself with these rules prior to operation of the unit. There are 6 combine models in the Case International line. They range in size from 124 horsepower to 208 horsepower, from 125 bushel grain tank capacity to 208. The combine line also features a hillside model and pull type. All combines perform 5 basic functions: cutting and feeding, threshing, separating, cleaning, and crop handling. Each of these functions must be correctly adjusted and operated in a proper relationship with the others. Let's begin with cutting and feeding. The combine process starts at the header. It is here the crop is cut, gathered, and fed to the rotor cage. A wide variety of corn and grain header models are available in the Case International line to meet all farming needs. The Case International grain header and flexible cutter bar grain header are available to serve varying crop and farming conditions at widths that range from 13 feet to 30 feet. The Combine Handbook lists the possible options and adjustments. Raising or lowering of the header is controlled with the header hydraulic lift control located on the right-hand console in the operator's cab. There are bottom shields on the grain header that protect the header bottom from damage on rocky terrain. Optional stone retarders and rock traps are also available to prevent damage to the combine. The reel holds the crop against the guards until the knife cuts the stems and sweeps the cut material gently onto the header. The auger moves the cut grain to the center of the grain header and delivers it to the feeder. The reel must operate fast enough to sweep the grain under the auger, but not so fast that the reel bats shatter the grain. Normally, the reel speed is 10 times the ground speed. When the reel is in its lowest position, the reel bats should be just below the grain heads. In down crops, the reel should be set low enough to sweep the crop through the knife and under the auger. The pickup reel is designated for use in down crops. The more down the crop, the further forward the reel must be set, and the closer the tines should be set to the knife. The tines should clear the header auger by not less than 1 inch. Pickup reel pitch is approximately 5 degrees. Too much pitch will prevent the reel from releasing straw under the auger. If straw is released too high on the auger, it may not feed properly across the header. The pitch of the reel tines is controlled by eccentric adjusting plates at each end of the reel shaft. A wide variety of corn header models is available in the Case International line. Capacities span 4 to 8 rows with widths that range between 28 and 40 inches per row. A 35-tooth drive sprocket is standard for the corn head. Optional drive sprockets are also available for adverse harvest conditions. Refer to the Combine Handbook and Operator's Manual for additional attachments and adjustments. After the corn or grain has been cut and gathered, it is fed to the rotor by means of the feeder chain. Efficient feeding is a result of proper feeder chain adjustments and correct feeder drum stop positioning. Proper feeder chain adjustment is between 1/32 and 1/8 of an inch between the feeder bottom sheet and the chain slat at the center of the feeder housing. The chain must also be adjusted so that the slats clear the feeder face by no more than 1 1/2 inches. If this is not adjusted properly, poor material transfer from the header auger might result. Most crops, including wheat, are set to the lowest drum stop position. Heavier crops, such as corn, will require setting the drum stop to the upper portion of the S-shaped positioner. As the rotor turns, the crop spirals through the rotor cage. In the rotor cage, it is threshed repeatedly by a set of 3-section concaves. It is here that 90% of the threshing occurs. The 3-section concaves have 2 functions. First, they must hold the crop material long enough to ensure complete threshing. Secondly, they must provide sufficient capacity to allow the crop to separate into the cleaning system once it has been threshed. For wheat harvesting, small wire concaves are used. For corn harvesting, large wire concaves are standard. To provide greater capacity, the factory only installs every other wire in concaves destined for use in corn. High-volume corn, however, may require removal of additional wires. Rotor speed and concave clearance settings will affect any combine's performance. But with Case International's multiple pass threshing, a broader acceptable range of settings is possible. So kernel and grain damage is greatly decreased and is not affected by rotor speed or concave settings nearly as much as in conventional combines. Concave clearance relates to the distance between the concaves and the rotor rasp bars. The threshing difficulty of the crop determines the appropriate clearance. For harder threshing conditions, a close setting is required. As you can see, adjusting concave clearance is not a difficult procedure. Rotor speed is adjusted by the operator from the cab's right-hand control console. Movement of crop material through the rotor cage is controlled by transport vanes located inside the rotor cage. Relocating the vanes by pivoting them into a more vertical position results in additional spiraling of crop material for increased threshing and separation. This position is suitable for harvesting crops like corn that require more threshing. A more horizontal position increases the flow of crop material rearward for less threshing. This position is a good choice for harvesting crops like wheat that require less threshing. In the rear half of the rotor cage are located 3-section grates. Separation work is completed in this area. 3 types of grates are available, interchangeable depending on the type of crop being harvested. With corn, the key stock bar grate is recommended because it allows easier passage of corn kernels. With wheat, the slotted grate is recommended. Channels are bolted to the outside of these grates to reduce the amount of chaff that passes to the cleaning system. The grates are in a fixed position and do not require adjustment. Concave and grate replacement and maintenance are relatively easy to accomplish. The 3-section concave can be removed and reinstalled by one person in approximately 30 minutes. The 3-section grates can be removed and replaced in even less time. After separation, the crop falls through the concaves and grates into auger beds below. The threshed waste material remains in the rotor cage and is moved rearward into a discharge beater. It is then moved out the rear of the machine. The augers move the threshed crop to the rear and onto the chaffer sieve in the cleaning system. Separation of trash material from the threshed crop is accomplished through the use of a cleaning fan. The fan's air velocity suspends the trash material on top of the sieves, which then move the trash rearwards. Fan speed is variable and can be adjusted from the cab. Recommended fan speed for corn is 1,000 RPM. The shoe sieve is suspended below the chaffer sieve on rocker-type hangers. The shaking action of the shoe operates in direct opposition to the chaffer. When the chaffer moves forward, the shoe moves rearward, which assures double cleaning action. First on the chaffer, where coarse material is removed, and secondly on the shoe sieve, where final cleaning takes place. For combines in corn, the 1 5/8 adjustable corn slat chaffer sieve is standard. This sieve provides more opening for corn to fall through while still suspending trash to provide high-capacity cleaning. A new 1 5/8 inch closed slat shoe sieve also is available and provides better cleaning of high-yielding corn. For combines and wheat, the shoe and chaffer sieves both are standard in 1 1/8 inch sizes. Chaffer and shoe sieves have recommended opening dimensions for various crops and are easily adjusted. With corn, the recommended chaffer opening is 1/2 inch. With wheat, the recommended chaffer opening is 5/8 inch. The recommended shoe sieve opening for both corn and wheat is 3/8 of an inch. Adjustments may vary depending on crop and field conditions, but remember, the finer the openings in the shoe sieve, the greater the amount of tailings or unthreshed material. Pieces of unthreshed crop are floated over into the tailings auger, where they are delivered back into the rotor for rethreshing. As noted earlier, unwanted material is suspended on sieve fingers and walked out the rear of the combine. The clean grain is heavier and falls through the shoe sieve, where it is transferred by the clean grain auger to the clean grain elevator. It is then transported to the grain tank. A hinged door is provided at the bottom of each elevator for easy inspection of elevator conveyor chains and for purposes of cleaning. Unloading is accomplished through the unloader tube. The unloader tube position is hydraulically controlled from inside the cab. The axial flow design also offers unique advantages in the even distribution of discharged material. With aggressive dual spreaders, straw bunching or windrowing is avoided, and plowing and tillage operations are made easier. The spreader's rubber blades also offer advantages. Being adjustable, they allow the operator to increase or decrease the spreading effect. They can also be removed for windrowing. To recap, the chart on your screen lists the initial settings necessary when using an axial flow unit for the harvesting of corn and wheat. And one last point. To keep the combine mechanism up to full speed during operation, run the engine at full throttle. All drives are based on engine-governed speed. Every operator of a combine has a different set of expectations by which he rates the unit's performance. One operator may value high quality of grain. Another might look for acre per hour productivity. A third might value the ability to harvest a number of crops under a wide range of conditions. Whatever the preference, all operators seek a minimal amount of grain loss. No combine will save every seed or kernel passed through it, but the axial flow concept affords the operator the greatest chance of success. The Case International provides the latitude to adjust for maximum combine efficiency. A universal rule is to set your combine to manual specifications first, then proceed to adjust as necessary for your harvesting situation. And remember, make only one adjustment at a time, then reevaluate. Corn and seed loss tables are provided in the operator's manual and combine handbook that cite normal crop loss per square foot, equal to 1 bushel per acre. However, it is up to the operator to determine acceptable levels of loss based on field conditions and time available for harvest, and adjust his combine and travel speed accordingly. When checking grain loss, it is important to determine the source of the loss before making adjustments. Losses also should be checked at several spots and averaged to ensure a proper adjustment is made. Three major areas can be identified in this chart: the area of pre-harvest loss, header loss, and separator loss. Pre-harvest loss may be due, of course, to insects, weather conditions, or other adversities. Search the ground in the unharvested crop for kernels or seeds that the header would be unable to gather. Use the seed and corn loss tables to determine the loss due to pre-harvest conditions. Header loss can be calculated by subtracting the kernels on the ground in area A from those in area B. The difference is header loss. Header loss in corn is usually due to operating too high. Operate the head as high as practical to prevent damage from low-lying obstructions, but not so high as to miss downed or low-lying crops. In small grain, poor cutting action and reel shatter can also contribute to header loss. To reduce header loss, always be sure the combine is operating at rated engine RPM. Make sure the unit's ground speed is suitable for the field conditions and crop conditions. A speed too fast will crowd the machine and result in excessive losses. Separator losses, such as unthreshed heads, originate in the rotor and cleaning system as a result of improper adjustments or a lack of proper attachments. To determine separator loss, check area C, windrow directly behind the separator. Subtract the pre-harvest loss, area A, and the header loss from crop found in this area. To determine if the separator loss is due to the rotor or cleaning system, fully open the shoe and chaffer sieves. If the loss remains high, it is due to the rotor. If the loss decreases, it is due to an improper cleaning system adjustment. No two harvesting situations are exactly the same. The range and effects of adjustments relating to harvesting conditions are so widely varied that only the operator can best determine the most suitable adjustments. A complete guide for troubleshooting a wide range of harvest problems is provided in both the operator's manual and the combine handbook. An optional electronic grain loss monitor is also available for sensing loss in relation to ground area covered. In the cab, you will note simplicity of operation and attention to operator comfort. The cab provides excellent visibility while offering the utmost protection from dust, chaff, and weather. With the rear-mounted engine, the operator is also protected from excessive noise and freed to concentrate on his harvest operation. The cab's air conditioning and heater work in conjunction with the pressurizer controls conveniently located in the front of the cab. An optional shaft speed monitor system is available with sensors mounted in 7 different locations on the combine. Continuously monitoring the unit's operation, anytime a designated shaft slows down or stops rotating, an audible alarm will sound to alert the operator. The digital display will indicate numerically which position and function is at fault. If more than one is at fault, a 0 is displayed. But with fewer parts and belts to wear out, the Case International Axial Flow Combine offers efficient, long-term, trouble-free operation. A basic 3-speed transmission, parking brake, unloader clutch, and swing controls are located on the cab's left-hand console. Optional equipment controls that can be controlled here include power guide drive wheels for optimum traction in wet ground conditions, and a 2-speed range propulsion motor for use on the 2 largest machines. On the right-hand console are located a full complement of instruments and controls that enhance and simplify the combining operation. Included here are hydrostatic propulsion controls, a digital readout for engine, rotor, and fan RPM, rotor variable speed switch, header lift control and automatic header height and sensitivity controls, separator drive switch, and feeder clutch switch. This, then, is the Case International Axial Flow Combine, a technologically innovative unit that results in increased productivity. A unit whose versatility means more opportunity for profitability. The Axial Flow Combine, a fresh choice for America's farmers from Case International, a fresh team for today's farmer.